The following program is brought to you by Element 14, the electronics community where you can connect and collaborate with top engineers from around the world. Join now at element14.com/presents.
Greetings, programs, and welcome back to Element 14 Presents. Matthew here, you there, and this is Leonardo da Vinci's design for an ornithopter, a flapping bird-type contraption, a flying machine before we really understood everything there was to know about flight. It's been around for a few hundred years now, and nobody's really been able to get it working. I propose an experiment. I am going to attempt to take a commercially available remote-controlled airplane and turn it into a working ornithopter. Now, I'm probably going to fail at this because, well, one, I'm a pilot, I'm not an aeronautical engineer. I'm better at flying them than I am at designing them. However, I do want to try. Will it work? Probably not, but it's gonna be a fun ride. So, strap in and let's get started.
Amazing hacks. Inspired designs. Each week, Element 14 Presents brings you innovative projects using electronics, engineering, and more.
Now, before I start to build something grandiose and at scale, I want to build a very small sort of prototype ornithopter, a little rubber band powered ornithopter, just to get an idea for the flight dynamics and how it's actually going to work and how I can translate that to a larger RC model. And to do that, I'm going to start with a project called the Freebird. And it's a little small DIY ornithopter. It's been kicking around since the 90s, and it probably dates further back than that. But it's a very simple design. It illustrates the flight dynamics very well. And I should be able to adapt those ideas into a larger RC type airplane thing. Elmer's glue, da-da-dee-da-da, Elmer's glue, Elmer's glue, ba-ba-ba-ba-bum, Elmer's glue. And through the miracle of television, we now have our completed Freebird ornithopter. It's a simple little design, just a very simple rubber band powered. You see there as I rotate the winding crank, it actually just pushes the wing struts out, up and out, and then pulls them back in again. Is that essentially what we have for the mechanism? Just a simple crank linear actuator on these two guys here, pushes the wings up, pulls them back down, up, down, up, down. And that's what gets it to actually kind of bob along, fly. This one you have to have a little bit of forward thrust with. You kind of gotta let it go at a little bit of a forward thrust there, give it a little shove, if you will, to get it to fly correctly. But I think we can overcome that with maybe a propeller on our larger model. Okay, so now I have kind of a basic idea of how an ornithopter is gonna operate. Now I just gotta figure out how to translate this into something a little more electronical. So we have motor, and then that's going to probably turn a crank. Let's do a little front view here. See, there's our motor shaft on a crank. And then we have basically a linear actuator, just boop, 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 going on the crank there. And then that should in turn take care of the up and down motion. As our actuator goes up, it'll push the wings up and likewise pull them down. So that's the idea there. That's the challenge, is to rig up something like this. Now, it wouldn't be as big a challenge, but my 3D printer is still kind of on the fritz, and I haven't been able to fix that yet. So we're gonna have to get creative. So fortunately, my buddy Trent, He runs the HeboCon here in Southern California, so I'm gonna get with him. He's got toys galore and should be able to find some parts that I can use to kind of put this together. Some gear, right? Maybe a rack and pinion, something along those lines. I should be able to salvage something from some toys. And then, of course, once we have this linear actuation going, then we'll have, you know, basically our wings there. We'll have a tail section, and then of course we'll have some kind of radio control going to it. So let's dig through the bin, start putting the drive section together, and that should get us at least started. I have managed to find the exact or very similar mechanism that I'm looking for. So you have these two sort of rack and pinion gears together, these two racked gears coming together, and they do this angular flappy kind of movement out of a Flappy Bird kind of toy. So we got that. So basically I need some way to just just a kind of a linear actuator on this particular part right here. Attach this to a crank that's attached to the motor. Hopefully I don't have to gear the motor down because I can't print any gears, but I might be able to find something on Newark Electronics that'll work if I need like a geared, something that's geared down, a little more torque and less speed, as I may need that. So that's where we are right there. So I need to build the mechanism around this, and then we should have something that has some flappy wings and not much else, but we'll get there. So I have this flappy mechanism here, and it turns with this rotating cam. I need to motorize that, and I have this little geared motor system from Newark Electronics that I've taken apart because I'm using, this is the output gear with the output shaft, the drive shaft. It would normally go right in here like that. So what I'm going to do is I need to cut the drive shaft so that it fits over the drive shaft for this cam mechanism. Put that together, hopefully get this to where it will actually turn. You got kind of a little flappy mechanism going on, motorized flapping mechanism. Because otherwise, if I do direct drive, it's gonna be like way too fast and not enough torque, and it's just gonna be crazy. So now that I've got this motor wing flappy assembly all put together, now the next thing I gotta do is actually put this thing into some sort of airframe. So I've got this this salvaged fuselage from a little cheapo RC airplane kit, and I'm thinking what I'm gonna do is just pop this guy right in here. I'll have to modify this a little bit. Pop him right in here in the back, or probably more like that, just to get it to sit in there nicely. Now there's enough room in here. There should be enough room for the motor assembly, motor flappy wing assembly, a battery, and a little motor here. There's an old saying in aircraft design: if you put enough thrust behind something, you can get anything to fly. And that's sort of the idea here. Is I've got these motors that I salvaged as part of this kit. It was like a twin pusher prop thing. So we'll have forward thrust off the nose. We'll have the flappy bit here amidships, sort of. Probably have to do a thing where you just get it kind of, straight and level, or get the wings level to take off, and then start flapping in order to get them to go. So that will do for that. And that's really the goal right now, is to just get the thing off the ground. If this tends to work, then I'll worry about steering later. It's coming along, and it's either going to fly or it's gonna fail spectacularly. So the next thing I've got to do is I've got to figure out a way to remotely control this drone. So I was originally thinking using like the Arduino Maker board with the Wi-Fi and creating a server and a client and communicating between the two. Kind of like what Clem did with the RC POV RC car that he made, which was really freaking cool. However, I realized that I'm hacking apart a remote-controlled toy. Thus, it already has a remote-controlled receiver in it. So why reinvent the wheel, especially if this receiver is geared toward, well, not geared, but this receiver is made to control 2 motors. Thus, I can easily control 2 motors with this same control board. That's where we are right now. So what I've got to do is I've got these 4 wires here. I mean, this is just the antenna, and of course this is the battery, and we have a little power switch. So I've got these 4 control wires. I'm assuming power and ground independently. Just looking at the board here, we got a couple of transistors. So I'm assuming what it is these are going to be power, positive out from the board to the motor, positive leads. These are going to be ground leads, and they are actually signal by the transistors. So they'll be turned on and off by these transistors, which would then be controlled by this guy right here. Now, fun fact about this little remote control deal here. It's a ridiculously super simple controller. You see this big 06 here? This is actually how you program it. So apparently at the factory, what they do is they have all these little oscillator crystals. And this is an AM transmitter on 27.095 megahertz. And so that's channel 6. So they really just plug it right in there, and then they just match up the same receiver, 06 receiver AM, and I'm sure it's 27 point blah, 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 on there, 27095, there it is. So they match it up with this receiver, channel 6 receiver AM, 27.095 megahertz. And they just plug that into the board, and then they put these both in the same box. This actually takes like, what, 1, 2, 3, 4, 5, 6, 7, 8, 2, 4, 6, 8. 8 AA, so that's 3, 6, 9, 12 volts that this runs on. So instead of just wasting a bunch of AA's, since I'm just messing around with this right now, I am just going to plug this guy into my bench supply here because it'll work. I just need 12 volts. So that's probably going to be like power out. And let's see, this is gonna be some kind of ground, I think, probably. And try the throttle, there we go. Okay, so throttle pushes up to about 5.5 volts. So there we go. So that is, that's full throttle on that line. That controls the 5 volt, which I'm assuming is just the forward flight, because it is the throttle. So on this side, the blue is telling me 4 volts. So 4 volts there if I turn it left. But if I turn it to the right, it actually drops it down a little bit. So that's what it's doing, is it's taking away a little bit of power from one of the motors in order to get it to turn in the opposite direction. I gotta figure out how I'm gonna do this. So I may have to put a transistor in there and be like, yeah, sure, we're gonna use this as the signal to do the transistor. I don't know, we'll figure it out. Because basically it's gonna be throttle on this side and it's probably gonna be wing control on this side. So we're gonna see how that works. So I was playing around with the leads here, trying to see if I could trick the system into doing what I wanted it to do. However, I may have actually let a little bit of magic smoke out of this little transistor here, this little MOSFET. Change of plans slightly. So here's what we're gonna do. So this switch actually only controls the receiver itself. So what I'm gonna do is I'm just gonna bodge this together. So whenever the battery is plugged in, the receiver board will be powered. Then what I'm going to do is I'm going to move this switch over to one of these guys, one of these motor leads. It goes out to the switch, which will be mounted here on the outside, and then into the motor to turn the propeller, which is now on this, the front propeller will now be on this lead. And now what that does is it kind of simplifies the control scheme for me. So you flip the switch, propeller starts spinning like crazy, giving it thrust forward. Then we will use the throttle to actually control the flapping of the wings. So that works. So this is actually going to be variable thrust or variable control, variable speed control for the flapping mechanism to get the wings to do their thing, which will be controlled by this lead here. That's where we are. So I gotta do a little bodgery, a little jiggery pokery, and we'll see if it gets off the ground. Here goes nothing. Hold on to your butts. That works. Ah, it flaps. It has a propeller and it flaps. Now he's got to put some wings on it, and we will see if it works. Okay, so before I put wings on this thing, I want to see how much thrust I can get off of this stock propeller to see if I can get enough takeoff speed. Now I got a nice wind coming right down the pipe. We're set up for a takeoff, so we're just going to see what kind of a roll we get just off of the motor. Contact. So apparently my propeller was twisted the wrong way, had a reverse washout. So I have replaced it with this one that is slightly larger, a little more surface area, should be a little bit more thrust. So we should see what then happens. Contact! I have no idea if this is actually going to work. I kind of feel like it's not going to work. I feel like there's going to be a lot of torsion on the wings and it's going to do weird things. It's going to become very unstable and it's going to fall out of the sky if you get us off the ground at all. So let's try it. Contact. Well, that didn't work. Quick pre-flight check. Okay, well, we got flap. May have to launch this by hand. So, as expected, it did not fare too terribly well for various reasons. One being lifting surfaces not quite stable enough, also not quite big enough. I did manage to get them a little more centered. The center of lift was a little bit better over the center of gravity than I had earlier anticipated or designed for. So that helped it fly a little bit, other than the thrust. Yeah, so flapping mechanism, I really liked this. I want to work on this a little bit more, design some original parts, probably put that together on the 3D printer as soon as that is up and running. I do like the RC setup here. It's just a simple AM transceiver set. So I want to mess around with that a little bit. It's super rock basic simple. I'm going to be doing a teardown of that, show you how it works a little bit more in depth on element14.com as well. So look for that. The propeller motor, the shaft has just been jammed down into the bearings. It feels like don't believe that will ever turn again. All in all, you know, it was a fun little experiment. It goes to show why exactly it's so very difficult to design not just a working aircraft, but an efficiently working aircraft. And I have so much more respect for the people who actually do this for a living now. Like I said, I just fly the darn things. I don't, I don't build them, I just fly them, ma'am. In the meantime, what other sorts of historical oddities would you like to see me attempt to build on the channel? Let me know in the community at element14.com/presents, link in the doobly-doo. While you're there, you can check out contests, tutorials, information, and so much more. My name is Matthew, and until next time, I've got an old computer I gotta go fix. Tally-ho, y'all.